My name is Anup, and I'm a principal network lead at Zapsec. And today we are going to look at one of the core concepts, probably on the LAN side, and plus it includes SD-WAN as well. The basic concept here, which we are trying to explain, is why your SD-WAN rollout failed. Maybe because you skipped the LAN. Let's have a look at it, and we'll have a brief discussion on that. Let me go ahead and share my screen in a few minutes. But before that, I want to talk about, every SD-WAN business case makes the same promise, right? 40% of WAN cost savings, application-aware routing, simplified branch connectivity, and technically, the SD-WAN fabric can deliver all of that, right? We agree on that. But here, what is most important business case which we leave out is SD-WAN does not control what happens between user and the WAN edge. That is your LAN. And if the LAN is not ready, the overlay does not matter. And I have seen a pattern across hundreds of branches that SD-WAN is performing exactly as designed. The user experience is still inconsistent, even if you just do the performances, exactly as what you wanted. And the root cause is sitting in the, wiring closet, not in the overlay. And I want to talk about that. In the first segment, I want to talk about where the LAN gap nobody, scoped, right? When most organizations plan SD-WAN migrations, the project scope starts with WAN edge device, extends towards provider fabric and the cloud on ramps and the policy engine. Everything, south of the WAN edge, the branch LAN gets footnote, like existing infrastructure is out of scope. The footnote is where the ROIs, the return on investment, goes to. Think about what your branch LAN actually does, right? It classifies traffic, it enforces QoS markings, and it connects wireless users to the wired backbone. It provides, the switching, the capacity, and determines whether your SD-WAN policies have a clear traffic to work with or, a mess of mismarked and oversubscribed flows, right? And if that LAN is running end of support, consider switches are inconsistent with QoS, and if the wireless controller is a generation behind, if the uplinks of the WAN edge, are saturated at peak, and then your SD-WAN is making intelligent, routing decision based on the garbage input which is coming in, and the user does not blame the LAN, they blame the SD-WAN, they blame the project, they blame you. And with that, I want to say there are three ways, the LAN breaks SD-WAN. Let me make this specific, right? There are three neglected branch LAN undermines and in an SD-WAN deployment. Number one is QoS misalignment. In this QoS misalignment, your SD-WAN fabric is making path selection, decision-based application on class. But if LAN switches are not making traffic consistently, or if they use a different QoS model, then WAN edge expects that the SD-WAN is optimizing based on, in incorrect classification. You get the right policy applied, but to the wrong traffic, right? The result looks like SD-WAN is underperforming, but it is a LAN's classification failure, not the SD-WAN failure, right? And on the number two, we have switching capacity and uplink saturation. Like legacy branches, I would say legacy branch switches were sized for on-prem apps and modern internet use. But today, those branches push SaaS applications, video conferencing, cloud backup simulations. If the LAN uplinks are saturated at 1 gig and aggregated demand exceeds that during business hours, you have a local bottleneck. No amount of SD-WAN intelligence can, route around. And with that, number three would be security and segmentation gaps. SD-WAN gives you application aware in security at the WAN edge. But if the branch LAN has flat layer 2, then domain with no segmentation between users and IoT or guest traffic, are compromised. basically. Devices have lateral movement paths on the SD-WAN. You never sees, right? Your WAN is segmented, but your LAN is wide open, right? Let's look at a few architectural diagrams. Let me walk you through them. Let me share my screen. Right. Here, on the left-hand side, you see a before state, like traditional MPLS. On the left-hand side, you see a traditional MPLS, branch. Traffic from users hits the LAN switch, go to the LAN switch, goes through the branch router, backhaul to the data center through MPLS. SaaS and internet traffic takes the same path. Everything happens through the DC and high latency on both DC access link and on the SaaS path. Look at the branch office box on the left. The LAN switch is feeding the branch router and, as one path, and back through the MPLS to the central data center. Every SaaS application and every web request or every cloud workload takes the same congested backhaul. And in that bottom left corner, you see three problems we just discussed are sitting right there. The QoS misalignment and uplink saturation, segmentation gaps, then all of that, right? Because the LAN is flat. That is LAN not ready state, right? And if I go to on your right, we have the after state, which is the local breakout and the LAN is aligned, plus LAN is aligned. The branch LAN switches feed an SD-WAN gateway with multiple path underlay transport like fiber, Ethernet, 5G LTE, SaaS and internet traffic breakouts, and or directly at the branch through the direct internet access. Only DC bound traffic goes to the data center, and and it goes over the optimized path with the dynamic path steering and low latency also. The critical differences at the bottom of each of the left side is LAN is not ready side and the LAN is aligned. The SD-WAN overlay on the right has the same capabilities as the SD-WAN deployment. The difference is that the LAN foundation underneath it is ready to support those capabilities. Like physical LAN alignment means the switching infrastructure classifies traffic correctly before it reaches the SD-WAN edge. Uplinks are seized for the traffic policy segmentation exists and at the LAN layer, not just the WAN boundary, right? Without that alignment, you deploy the architecture on the right, but and get the performance of the architecture on the left. The overlay is modern, the underlay is a bottleneck. And let me come to this point, final point, where I want to ask what good looks like, right? The fix is not complicated. It is like a sequencing problem. Before you design the SD-WAN overlay, you run a branch LAN readiness assessment, right? You just run a branch LAN readiness assessment. This three questions at every site. First, does switching infrastructure capable of consistent QoS or not, like making it aligned to the SD-WAN policy model? And the second question would be, you want to ask is, do the LAN uplinks have sufficient capacity of the for the current and projected traffic, including SaaS, and cloud workloads, etc. And third question you want to ask is the branch segmented at the LAN layer, or you are relying on, entirely on WAN edge for the security boundaries, right? If your answer is no for all these three questions or one of these questions, that is preconditioned to address before deployment, not after, then we have done this across, the Exapsec has done this across environments with 2,000 or more branches. It adds 2 to 3 weeks upfront. It saves months of troubleshooting on the backend. And I want to close this conversation on one question. If you are planning your SD-WAN migration or, already in one where the results do not match the business case, ask one question: what is our branch LAN readiness posture is, and who has assessed it, right? If nobody assessed it, you have found your problem. If someone has assessed it and everything was green, go look at the QoS markings at 3 random sites. Maybe you have like 10 random sites. Just check your 3 random sites and see if reality matches with your report, right? The diagram we walk through is difference between a successful SD-WAN deployment and 6 months of finger pointing. One side has a LAN alignment, the other does not, and every other variable is the same. Like SD-WAN is a network modernization project. That means the whole network, not just the overlay, right? It's a very simple diagram, not very complicated to understand. But LAN assessment is very crucial when you do your SD-WAN network modernization. I want to close on one note. SD-WAN network modernization project, that means whole network, not just the overlay. And thank you for watching this series. We'll see you in the next one.